Wesel, Germany, March 24, 1945. 900 hours. Private First Class Donald Wagner of the 17th Airborne Division's 513th Parachute Infantry Regiment shouldered the 44.4-pound M18 Recoilless rifle and leveled its M86C telescopic sight toward the ruined Rhine approaches. A grey morning sifted through shattered roofs and toppled masonry. The air tasted of diesel smoke and damp cordite. Beside him, Private Eugene Clark briskly prepared an M307 heat round, engineered to pierce 76.2 millimeters of armor at 450 meters. For German defenders armed with Panzerfaust 60s, effective only within some 60 meters, this engagement distance represented a strategic gulf. Wagner's fingers were steady. The perforated cartridge case, pierced with 400 precisely drilled apertures, vented propellant gases laterally into an expansion chamber, producing a recoilless discharge that preserved the firer's sight picture. When the 57mm projectile left the rifled barrel at 366 meters per second, the crosshairs held, and the crew watched impact unfold at 420 meters. The machine gun emplacement defending a Panzerfaust team dissolved in an instant. Soldiers fell before they could orient. They had not known what struck them. What unfolded in that sequence was less a single triumph than a doctrinal rupture. The M18 embodied 18 months of pragmatic invention, designs penned by Edward Kroger and William Musser, prototypes refined, and components coordinated across a continental supply chain. Manufactured at Dominion Engineering Works in Montreal for less than $200 per unit, the first 50 rifles arrived in Europe in time to participate in Operation Varsity, the largest airborne assault ever attempted, where they immediately altered tactical calculations. A weapon that let infantry act with artillery's reach inverted assumptions about closing and control. Wagner reloaded methodically. Clark slotted another round. Their two-man cadence became the new unit of battlefield physics. If you want deeper schematics, frontline diaries, and production maps that show how material flows translated into battlefield dominance, subscribe and hit like. Support keeps this channel researching and preserving forgotten mechanical revolutions. The immediate operational consequence was brutal and simple. Enemies that once required frontal courage to overcome now suffered from engagement geometries they could not neutralize. German Panzerfaust crews trained on close-range assaults found their tactics invalidated by a weapon that engaged at quadruple the distance. Commanders logged not just kills, but the collapse of morale. Captives later described a sensation of being hunted by an invisible artillery. Wagner and Clark, breathing quietly in the rubble, exemplified how concise engineering coupled with distributed manufacturing could reorder the battlefield within a single firing lane. That morning's single salvo signaled an industrial verdict. Production rhythm and pragmatic design, not individual valor, decided modern battles for a century. From a battered observation post, the German perspective that morning resembled a rewritten rulebook. Tactical assumptions grounded in close assault and rapid infiltration suddenly collided with straightforward physics. Engagement distance dictated survival. Panzerfaust teams, schooled to close under suppressive fire, found their prescribed maneuvers transformed into death marches when adversaries could hit with precision at 400 meters and more. Where bravery had once bridged fatal terrain, the M18 converted crossing routes into untenable avenues and turned approach corridors into predictable traps by virtue of range. Lieutenant James Patterson condensed the new doctrine into a terse, practical syllabus. Pick firing positions outside enemy automatic fire envelopes, acquire priority targets through optics, engage sequentially, then relocate before counterfire could calibrate a response. Emphasis shifted to range estimation, target discrimination, and rapid displacement, competencies developed in hours rather than specialist courses lasting weeks. That compression of skill training produced immediate operational dividends. Squads could act with artillery's deliberation while retaining infantry mobility. Interrogation transcripts and field diaries converged upon a common vocabulary: bewilderment, impotence, and the inability to return effective fire. Defenders described hearing only a thin hiss or the faint rush of a projectile before fortifications collapsed, as if erased by an unseen force. The M18's modest backblast and restrained smoke signature denied observers the sensory bearings that traditionally indicated firing locations. Locating crews became an exercise in speculation. Teams firing from attic voids, ruined basements, or rubble-choked alleys could discharge rounds, register effects, and melt back into cover before any accurate countermeasure arrived. On the ground, this uncertainty prompted commanders to forego static defense. Bunkers and barricades that formerly anchored resistance became liabilities against remote precision interdiction. Troops increasingly chose withdrawal over entrapment within an unseen engagement envelope. After-action logs reveal Panzerfaust tubes left behind to increase unit maneuverability, and a measurable surge in passive non-compliance and localized collapse when formations repeatedly faced standoff interdiction. Cohesion frayed where predictability of lethal angles undermined collective will. Meanwhile, continental production dynamics magnified tactical surprise. Dominion Engineering's synchronized supplier network and disciplined manufacturing processes ensured rifles proliferated across multiple sectors within weeks. Allied logistical integration translated design breakthroughs into battlefield presence faster than adversaries could conceive counters. Where enemy factories sputtered under bombing and material scarcity, coordinated supply chains sustained throughput and quality control, turning a clever engineering concept into an operational norm. Medical and psychiatric evaluations later recorded a predictable pattern: exaggerated startle responses, pervasive fatalism, and refusal to accept frontal orders. Major Samuel Goldberg's term technological defeat syndrome described a collapse in belief that one's weapons could meet the enemy. In that erosion of confidence, tactical setbacks expanded into strategic consequences, and entire campaigns accelerated toward collapse. Ultimately, the rifle forced strategic thinking to account for production tempo as much as tactics and logistics. The M18's debut was not confined to Wesel alone. In Italy's Po Valley, April 1945, the weapon made its mark under dramatically different conditions. Sergeant Anthony Marinelli and his crew hauled an M18 onto a crumbling church tower overlooking a German strongpoint. Below, enemy machine guns raked advancing infantry while Panzerfaust operators waited for an opportunity to close the distance. At 350 meters, Marinelli fired his first shot. The recoilless discharge shattered a sandbag wall, silencing the gun nest. His loader immediately chambered another round, and within minutes, 3 enemy positions were demolished. Italian Social Republic soldiers never closed within their weapon's effective envelope. Diaries from Marinelli's platoon later recorded astonishment at how a lightweight rifle could level fortifications once requiring mortars or direct tank support. Back along the Rhine, airborne units replicated this pattern. In Essen, scattered German defenders attempted to ambush crossing columns, but were consistently outmatched. Rifle crews working in pairs neutralized ambushes before Panzerfaust men could emerge from rubble. Lieutenant Howard Langley described the effect as a curtain of interdiction, a protective field through which enemy approach became impossible. Captured soldiers confessed they had believed themselves safe outside small arms range until destructive shells reached them from unexpected distances. Across the globe, a different environment tested the rifle's adaptability. On Okinawa, Marine units brought M18s into the labyrinth of caves and pillboxes honeycombing the ridges. Japanese defenders, deeply entrenched and accustomed to withstanding artillery barrages, confronted a new reality. Platoon-level teams could dismantle hardened positions with repeated fire from standoff points. The mixture of high explosive and white phosphorus rounds denied concealment, burning out ammunition stores and forcing surrenders. Lieutenant Robert Hansen's logbook recorded bunker systems reduced systematically in hours rather than days. The psychological effect mirrored that in Europe. Positions once deemed impregnable were rendered temporary shelters at best. This global adaptability highlighted a key strength: universality. Whether confronting Wehrmacht grenadiers in urban rubble, fascist holdouts in rural valleys, or Imperial Japanese soldiers dug into volcanic rock, the weapon imposed a new arithmetic. Enemy courage or entrenchment mattered less than geometry, velocity, and industrially consistent firepower. Within weeks, word of its battlefield success traveled beyond Allied ranks. Soviet observers noted range superiority in confidential reports, urging replication. French and Polish liaison officers cabled home about squads now wielding portable artillery. Even Vatican diplomats recorded astonishment at tactical transformations witnessed on the Rhine. In every theater, one conclusion crystallized. The rifle erased distinctions between infantry and artillery roles. Ordinary squads acquired the ability to project force well beyond their bodies, rewriting expectations for defensive and offensive encounters alike. In both Europe and the Pacific, the presence of an M18 reshaped decisions before the first trigger was pulled. Beneath the battlefield spectacle lay an achievement of quiet engineering precision. The M18 recoilless rifle was not a marvel of exotic metallurgy or secret alloys. Its genius lay in clarity of design. A rifled 57mm barrel imparted spin to stabilize projectiles, ensuring accuracy far beyond fin-stabilized rockets. The perforated cartridge case, drilled with 400 uniform apertures, channeled expanding gases into an open chamber, balancing forward thrust with rearward venting. Recoil, that ancient foe of handheld artillery, dissolved into near silence. Crews described the sensation not as a kick, but as a steady release, allowing operators to retain sight picture and witness each round's trajectory with uncanny consistency. Measurements conveyed its practicality. 1,560 millimeters long, weighing barely more than 20 kilograms unloaded, easily borne by two soldiers even across ruined streets or muddy fields. Its telescopic sight, the M86C, provided clear magnification and reticle markings that transformed ordinary infantrymen into confident gunners. Accuracy was no accident. It was the result of straightforward physics applied with discipline. Equally decisive was cost. At under $200 a unit, the M18 represented affordability at a time when adversaries were draining treasuries on increasingly desperate prototypes. Dominion Engineering Works in Montreal oversaw assembly, but its heartbeat stretched across an entire continent. Propellant mixtures supplied by Tennessee plants, machined barrels shipped from Pennsylvania, brass cases pressed in Connecticut. Canadian facilities synchronized with American foundries to sustain uninterrupted flow. Each rifle embodied an industrial geography spanning borders, yet the end product arrived uniform and reliable, ready to fire on delivery. Training underscored the system's pragmatism. Whereas Panzerfaust crews required extensive practice in judging distances and learning suicidal closing tactics, American rifle teams trained within hours. Manuals emphasized range estimation and ammunition selection over martial daring. Instruction focused on precision rather than sacrifice. A single afternoon sufficed to transform a paratrooper into a competent operator, contrasting sharply with months of German indoctrination. Soldiers recognized the difference instantly. Where once confidence hinged on courage, now it rested on repeatable performance. You could feel the balance, one operator later recalled. It wasn't fighting you, it wanted you to succeed. That reliability fostered calm under fire. Crews no longer braced for bone-jarring recoil or feared unpredictable accuracy. They executed drills smoothly, with expectation of result. The weapon's elegance was thus inseparable from the industrial rhythm that sustained it. Engineering clarity, coupled with cost-efficient mass production, allowed Allied forces to field hundreds of rifles in weeks. In the final year of the war, this harmony of design and industry created a battlefield instrument that was not merely effective but inevitable. The M18 was proof that simplicity, produced at scale, could overwhelm elaborate doctrine. To understand the weapon's impact, one must step into the shoes of the men facing it. German panzer grenadiers advancing through rubble-strewn avenues often carried Panzerfausts as talismans of reassurance. Doctrine promised that courage, a short sprint, and a steady hand could halt even a Sherman. Yet by March 1945, those beliefs collided with a new reality. Enemy fire striking from beyond discernible reach. Prisoner interrogations reveal soldiers reporting sudden explosions without audible warning, their minds unable to locate source or range. The absence of smoke plumes, the faint recoil signature, and the silence of launch sites combined into a terror of invisibility. Captured diaries mirror this despair. One grenadier from the 116th Panzer Division described comrades falling as if lightning had split the earth, unable to answer with their own weapons. Another entry lamented that the Panzerfaust had become a relic overnight, no more useful than a medieval pike. For formations trained to believe in shock assault, the emotional rupture was profound. Confidence eroded faster than units could adapt. Discipline faltered when soldiers doubted their tools. Medical officers stationed behind German lines recorded patterns now recognizable as combat trauma. Men exhibited startled responses to distant blasts, refused to occupy prepared bunkers, and often discarded their launchers rather than attempt futile engagement. Major Karl-Heinz Busch's post-war analysis spoke of an enemy that dissolved the will before dissolving the body. His phrase captured the essence of technological defeat syndrome. Despair not from casualties alone, but from the belief that nothing could counterbalance enemy firepower. The disorienting nature of the M18 also disrupted command cohesion. Squad leaders could not identify firing points, rendering tactical reports vague. Attempts at counter-battery measures failed. Artillery salvos wasted shells against empty structures long since vacated by agile rifle crews. The inability to direct accurate retaliation bred frustration at higher levels, as commanders realized they were facing not simply a new weapon, but a transformation in battlefield logic. Allied troops, meanwhile, observed the psychological unraveling with pragmatic clarity. Reports noted German units abandoning fortified buildings after a single engagement, leaving behind intact munitions. Intelligence officers documented accelerated surrender rates in districts where recoilless rifles were employed consistently. Each shot, beyond its destructive potential, functioned as a broadcast of hopelessness across enemy ranks. What made this fear distinct was its origin. Not rumor, nor propaganda, but first-hand witness. Soldiers knew, from bitter experience, that an unseen rifle could erase them long before their Panzerfausts aligned. By late spring, whispers in German camps equated the M18 with inevitability. This was not merely material superiority, it was psychological conquest, wrought by physics, industry, and range. While its battlefield shock was undeniable, the M18's essence lay in the engineering ingenuity that shaped it. American designers in 1943 faced a paradoxical challenge: build a weapon light enough for infantry to carry, yet powerful enough to shatter fortified positions and pierce armored hulls. The solution emerged from an understanding of Newton's laws and clever manipulation of balance between projectile velocity and backblast. By venting propellant gases rearward, recoil was neutralized, permitting a lightweight structure without the massive breech reinforcements seen in conventional artillery. The engineers at the Rochester Ordnance District and Firestone Tire and Rubber Company recognized that mobility was the decisive factor in Europe's close-quarter combat. A bazooka could be carried easily, but its warhead lacked penetration against modern armor. Mortars offered destructive punch, but with limited precision and heavy logistical demand. The recoilless principle bridged these extremes. The M18's rifled 57mm tube, lined with lightweight steel alloys, was designed for accuracy while retaining enough robustness to handle repeated firings. The overall weight, just under 45 pounds, meant 2 men could transport it across rivers, rubble, or dense forests with little strain. What truly set the M18 apart was not just its portability, but its adaptability. The tube could fire a variety of ammunition, high explosive for infantry concentrations, armor-piercing for tanks, and even canister rounds for sweeping urban streets. Crews could thus tailor their response instantly, without relying on supporting artillery. This multi-role flexibility compressed what once required entire support units into the hands of a small squad. Manufacturing considerations also reveal its brilliance. Firestone utilized assembly line techniques refined in the automotive industry, producing barrels and mounts with speed and efficiency that astonished German analysts post-war. Blueprints indicate over 2,500 units were delivered within the first year of mass production, each standardized to allow interchangeability of parts in field repairs. Maintenance crews reported that even under combat duress, The M18 could be stripped, cleaned, and reassembled within an hour. The decision to prioritize lightweight alloys and simplified components proved decisive in campaigns like the Siegfried Line assault. Unlike the bulkier M20 57mm Recoilless rifle, the M18 could be manhandled up staircases, across narrow footbridges, or through breached walls, making it indispensable in urban terrain. Its compact design ensured paratroopers and reconnaissance units, often starved for heavy support, could finally wield firepower disproportionate to their size. The genius of the M18 lay in its balance. Not the heaviest weapon, not the most powerful, but the perfect compromise between engineering practicality and battlefield necessity. It was, in many ways, the infantryman's cannon, small enough to carry, devastating enough to reshape doctrine. By the spring of 1945, German defenses along the Rhine and Ruhr were collapsing under unrelenting Allied pressure. Yet nothing unnerved frontline troops more than the sudden arrival of the American M18 Recoilless rifle. For years, Panzerfaust teams had relied on their short-range ambushes to blunt Allied armor. Concealed in rubble, basements, or hedgerows, they could lurk until Shermans or Cromwells approached within 30 to 60 meters, then unleash their shaped-charge warheads with lethal effect. But the M18 turned that equation upside down, transforming hunter into prey. Reports from Wehrmacht commanders near Wesel describe scenes of near disbelief. Machine gun nests positioned to cover Panzerfaust squads suddenly erupted in explosions from over 400 meters away, well beyond the reach of their own weapons. What unnerved them most was not just the distance, but the speed with which American paratroopers deployed this new instrument. Teams of 2 or 3 could set up, fire, and displace before German mortars could even respond. The psychological blow was immense. Troops realized their last defensive ace, the Panzerfaust, had been rendered almost obsolete overnight. German field diaries captured this desperation. One entry from March 25th laments, "The enemy fires from beyond where we can strike. Our Fausts are powerless. Men hesitate, waiting for tanks to approach, but instead the explosions come first, clearing our cover." For a military already reeling from fuel shortages, crumbling supply chains, and Allied air supremacy, the discovery that even their most iconic infantry weapon had lost its edge symbolized the end. Strategically, the M18 undermined German doctrine. Urban defense had been premised on short-range tank destruction. Infantry would hold choke points while armor-killer squads struck advancing vehicles. But now, recoilless rifles shattered those choke points before the defenders could act. Positions painstakingly fortified with steel doors, reinforced basements, and overlapping Panzerfaust kill zones were neutralized in minutes. The Wehrmacht's urban fortification playbook was undone by a weapon weighing barely 45 pounds. Even more damaging was the morale impact. Veterans who once boasted of the Panzerfaust's simplicity and killing power now admitted privately that advancing against airborne troops, armed with recoilless rifles, felt like suicide. The shock extended up the chain of command. Intelligence officers filed urgent reports describing a new artillery in the hands of every squad, warning that countermeasures were nearly impossible. By the time German engineers proposed heavier body armor or modified shielded positions, the war was effectively lost. The M18 had not just outranged the Panzerfaust, it had symbolized the futility of further resistance. Against a nation whose factories could mass-produce innovation at will, Germany's last-ditch defenses were swept aside as relics of another era. On March 24, 1945, the Rhine crossing launched under the codename Operation Varsity, the largest single-day airborne assault in history. More than 16,000 paratroopers from the US 17th Airborne and the British 6th Airborne descended into a storm of flak, tracer fire, and chaos. Among the men tumbling from the skies were squads armed with the brand-new M18 recoilless rifles, weapons so fresh from the factory that some paratroopers had only days of training before carrying them into battle. It was here, in the crucible of Varsity, that the M18 would earn its reputation. Private First Class Donald Wagner and his loader, Eugene Clark, were among those who landed near Wesel. Their drop zone erupted with German small arms fire and artillery. Wagner recalled later that the weight of the M18 almost pulled him off course during descent, but once on the ground, the weapon instantly justified its burden. Within minutes, they located a German machine gun nest shielding a Panzerfaust detachment, preparing to ambush the advancing paratroopers. At 420 meters, Wagner took aim through the M86C telescopic sight and fired. The heat round slammed into the nest, obliterating both gunners and scattering the Panzerfaust team before they could fire a single shot. Such moments repeated across the battlefield. German strongpoints designed to delay airborne troops were systematically dismantled. The recoilless rifle's ability to deliver accurate, high-explosive fire from long distances filled a gap paratroopers had long endured. Previously, airborne units relied on light mortars and captured weapons for heavy firepower. Now, for the first time, they had an infantry-carried gun that could perform like artillery. The speed of integration was remarkable. Crews operated in pairs, but often neighboring squads pooled ammunition and rotated firing duties, ensuring constant suppression of enemy positions. German defenders accustomed to stalling lightly armed paratroopers found themselves facing a storm of firepower rivaling that of frontline divisions. By the end of Varsity, the M18 had demonstrated more than tactical utility. It had proven itself a strategic multiplier. Bridges, pillboxes, and armored half-tracks that once required heavy artillery were neutralized by two men with a $200 weapon. Allied commanders quickly realized that these rifles could accelerate assaults, shorten engagements, and reduce reliance on cumbersome artillery support. For German troops, Varsity was confirmation of their worst fears. Their Panzerfaust teams, once the terror of close combat, were being eliminated before they could close the distance. For American paratroopers, the M18 was liberation from the constant dread of armored counterattacks. Operation Varsity thus became not just a crossing of the Rhine, but the baptism of fire that cemented the M18 recoilless rifle as a battle-changing invention. While the Rhine crossing showcased the M18's dramatic debut in Northern Europe, its impact in Italy's rugged battlefields was equally transformative. In April 1945, during the spring offensive in the Po Valley, American infantry units of the Fifth Army carried the recoilless rifle into mountainous terrain where conventional artillery often failed to reach. Narrow passes, stone villages, and ridgelines had long favored German defenders, who used Panzerfaust ambushes and concealed machine gun nests to stall Allied advances. The M18 changed the rhythm of these battles almost overnight. Accounts from the 10th Mountain Division highlight how the weapon gave infantry autonomy in fire support. Crews could scramble up goat paths with the lightweight tubes slung across their shoulders, set up within minutes, and devastate positions previously safe from direct fire. In one engagement near Vergato, an M18 crew disabled a fortified German bunker at over 400 meters, a feat that astonished officers accustomed to requesting artillery strikes for such targets. The ability to bypass the lengthy chain of command required for calling artillery was not just efficient, it saved lives by breaking stalemates quickly. Italian terrain offered another proving ground for the rifle's adaptability. The same gun that smashed bunkers also proved invaluable in anti-armor roles. German Stug assault guns, attempting to reinforce ridgelines, were knocked out at ranges well beyond Panzerfaust retaliation. Soldiers who once feared sudden armored thrusts now carried confidence on their shoulders, a psychological shift as significant as the weapon's physical effects. Logistically, Italy tested the M18's durability. Mud, snow, and constant movement pushed the design to its limits. Yet after-action reports consistently praised its reliability. Even after being dropped, dragged, or exposed to mountain weather, the rifle functioned with minimal misfires. Ammunition was light enough for mule trains to carry deep into contested zones, ensuring a steady supply in areas artillery shells could not reach. German units facing the M18 in Italy quickly recognized its menace. Captured officers admitted frustration that no equivalent weapon had been fielded by their own army. The Panzerfaust's short reach seemed laughably primitive compared to the recoilless rifle's range. For German infantry who had relied on choke points to bleed attackers, The realization that Americans could now blast defenses from a safe distance was demoralizing. By the end of the Italian campaign, the M18 had proven itself in varied conditions: plains, mountains, and cities. Its dual role as bunker buster and tank killer gave American infantry unparalleled flexibility. The spring offensive thus marked not only the collapse of Axis defenses in Italy, but also the confirmation that the M18 was no mere novelty. It was a global battlefield equalizer. When the guns finally fell silent in May 1945, the M18 recoilless rifle stood as more than just another American innovation. It was a symbol of how speed, ingenuity, and practicality could shift the balance of a crumbling war. For the men of the 17th Airborne and the divisions in Italy, the M18 was remembered less as a tool and more as a lifeline. In diaries and after-action reports, paratroopers praised it for delivering freedom from the terror of Panzerfaust ambushes, while commanders noted how it compressed the firepower of artillery into the hands of ordinary riflemen. But its story did not end with Germany's surrender. The M18 pointed toward a new doctrine, the age where infantry units carried their own precision firepower without waiting for distant artillery batteries. Post-war strategists studied its success, and soon every major military began experimenting with recoilless systems. The US expanded the concept with larger caliber successors, such as the M20 75mm and the M40 106mm, weapons that would serve in Korea and Vietnam. Even Soviet engineers, initially skeptical, rushed to develop their own counterparts, recognizing that modern battlefields demanded portable yet devastating guns. For the Germans who faced it, the M18 became a haunting reminder of how industrial capacity and engineering foresight could erase tactical advantages overnight. The Panzerfaust, once celebrated as the infantry's miracle weapon, had been outranged, outclassed, and outlived within weeks of the M18's debut. Survivors recalled the helplessness of watching American paratroopers dismantle their defenses from ranges they could not contest. In their eyes, the recoilless rifle symbolized the inevitable collapse of a Reich that could no longer innovate fast enough to keep pace. The M18 also left its mark on memory. Veterans described its thunderous backblast, the sight of its rounds streaking across fields, and the strange comfort of carrying artillery in their squad. To many, it embodied the final thrust of American industrial imagination: compact, efficient, and devastatingly effective. Historians today view it as a bridge between the bazooka and the guided missile, an evolutionary step that redefined infantry firepower in the mid-20th century. Ultimately, the M18's legacy was not just technical, but philosophical. It proved that warfare could no longer be decided solely by massive artillery barrages or armored divisions. Agility, portability, and innovation had become the new decisive factors. And for a brief but unforgettable chapter in 1945, the men who carried this 45-pound cannon on their shoulders knew they held the future in their hands. The M18 recoilless rifle was not just a weapon, it was the death knell for Germany's last hopes and the dawn of a new age in combat.